In this video, we are going to discuss about Schmitt trigger. So, this is a block diagram of Schmitt trigger. So, it consists of an inverting comparator. That is why I am telling you this inverting comparator is. Here I am going to give the input to the uh, inverting terminal. Okay. So, it is nothing but an inverting comparator with a positive feedback. Feedback means the output is connected to the positive side of the positive terminal. Okay, other end of the input is connected to the positive terminal, so it is having a positive feedback. So this circuit is also called as squaring circuit, because it is used to convert any irregular signal into a square wave. So the purpose is it will convert irregular shaped waveform into square wave. And I already told you it is a it uses a positive feedback, right? So you can see I have told you it is a comparator. Okay, so you can see I can derive the value of VR first. How to derive the value of VR? VR according to the voltage divider rule, I can write VR is equal to V naught into R2 divided by R2 plus R1. So this R2, this term R2 divided by R2 plus R1, I can write it as beta into V naught. Okay. So I need to find what is V naught. Okay. So we know that V naught is equal to A times V plus minus V minus. Okay. A is a gain, voltage gain. So V plus represent this one and V minus represent this one. Okay. So whenever if the V plus value is greater than V minus, you will get the output as so output goes to V sat. Okay. And whenever the V plus value is less than V minus, so output is equal to minus V sat. Okay. So here I am going to give the irregular signal. Okay. Irregular signal to the input. Okay. So this is my V in. Okay. And it is given through a RCOM, where RCOM is equal to, RCOM is a resistance value. So this resistance is nothing but it is equal to R1 in parallel with R2. Okay. So what is the purpose of RCOM? Okay. So the RCOM is used to minimize the offset problem. Okay. So first let me consider that VR. I'm going to consider V naught is in this V naught is equal to V sat. Okay. So this is a condition that I am assuming. Okay. So what is my VR? VR is equal to, you can see VR equal to beta into V naught. So I can write VR is equal to beta into V sat. Okay. Beta into V sat. This I am going to take this one as So if VR value is beta VSAT, okay, beta VSAT, and whenever the input signal, okay, whenever the input signal crosses this, crosses this beta VSAT, it is more than uh, this value, okay. So whenever the V in, okay, the V in value goes greater than this VR. Now VR is nothing but beta VSAT. So what will happen? So Vn is given to the negative value. So if negative is more than the positive value, V naught will goes to, if negative is more than the V plus means the output goes to V set, okay, minus V set. So now the output goes to minus V set, okay. So I can write this beta VSAT value. What is beta VSAT value? Beta VSAT value is equal to VULT, okay. So you can have another condition, right? This is the first condition. The second condition is, suppose if V naught is equal to minus V set, okay. So what is VR? VR is equal to minus beta V set, right? So if so whenever this the input voltage, okay, so the input voltage is less than this minus beta V set, okay. So whenever the V in, that is V plus value is greater than V minus means, okay. So whenever the V in value goes less than this VR, so the output will goes to V set, right? So this is nothing but my VLT, okay, LLT, okay. So I am having a two threshold voltage here. One is VULT and another one is VLLT. Okay, since this value is greater than this one, right? So consider this is my input, okay. This is my input sine wave. I am going to fix this as VULT value, and this is nothing but VLLT value, okay. So here you can see my input voltage. This is my input voltage V in, right? So the V in voltage is greater than. Now we can see after this point, you can see my Vn is greater than Vr, right? So the output goes to minus Vset. So during this point, okay, so during this point, you can see initially it has to be Vset, right? The output has to be Vset, and whenever the input goes more than the VULT, it will go to minus Vset, right? Again, you can see during this point. So during this point, you can see the input voltage is less than the VLLT, right? So whenever the input voltage is less than, so this is something but VLLT, right? So whenever the input voltage goes less than VLLT, the output goes to VSAT. So up to this point, it will be hold like this. So okay, it goes to VSAT. Okay, so and this process will continue. Okay, so you can see I'm getting a square wave. Okay, so this comparator with positive feedback is said to exhibit hysteresis. So this is also called as dead band. Okay, hysteresis. So what is dead band means? Okay, so I can write this V hysteresis. Okay, V hysteresis equal to VULT minus VLLT. Okay, so this is nothing but hysteresis voltage. See, if you see, uh, okay, suppose this is my V out and this is my V in. Okay, so you have two threshold voltage, right? One is VULT and another one is VLLT. So initially I'm considering my the input voltage, the output voltage is in VSAT. Okay, output voltage in VSAT. I am increasing the V in value. So whenever the input voltage, okay, whenever the input voltage is greater than um, this VULT, okay. So whenever the input voltage goes more than this VULT value, what will happen? Output goes to minus VSAT, right? So whenever the input voltage, okay, the input voltage, so I am increasing towards here, okay, the input voltage is increasing till now, the output voltage is in VSAT, okay. So whenever the input voltage goes beyond this VULT, the output goes to minus VSAT. Okay, this is my minus VSAT value, right? And again, if we see, so my input voltage I am going to decrease. Okay, so if I am decreasing the input voltage, okay, I'm decreasing the input voltage whenever it goes below the VLLT value. So what happens whenever the input voltage goes less than VLLT? Now the input voltage goes less than VLLT, the output goes to VSAT. So if the input voltage goes less than VLT means the output again it will go to plus VSAT. So this part is called as hysteresis. Okay. So let us discuss some problem based on this. Okay. So they have given my R1. Okay. For the circuit, for the above circuit, if R1 is equal to 100 ohm and R2 is equal to 56 kilo ohm and my V in, okay, the V in is equal to 1 volt peak to peak value sine wave. Okay. So with the supply voltage, it is having a supply voltage of plus or minus 15 volt, and they are asked to determine VULT and VLLT. So since I'm using opamp IC741, VSAT value is equal to 14 volt, the maximum voltage, and VSAT minus VSAT value is um, minus 14 volt. Okay. So I need to find VULT, right? So what is VULT? VULT is the formula is beta into Vsat. Where what is beta? Beta is nothing but R2 divided by R2 plus R1. So this is 100, sorry, 100K, 56K, and this is 100. Okay. So that is nothing but beta into Vsat. Okay. So what is beta? Beta is equal to R2 divided by R2 plus R1 into Vsat. Vsat is 14, right? So how to solve this one? R2 value is 100. So 100 divided by 56,000. 56,000 plus 100 into 14. So if you solve, you'll get the answer as 25 millivolt. And what is VLLT? That is equal to minus beta Vsat. That is equal to minus 14 into R2 divided by R2 plus R1. That is equal to minus 25 millivolt. So we can find the value of V hysteresis, right? V hysteresis is equal to 25 minus 25 millivolt. That is equal to 50 millivolt. Okay. So if you draw this one, this is nothing but plus 25 millivolt, and this is minus 25 millivolt, and this is nothing but 50 millivolt, and this is minus 14 value, and this one is 14 volt.